Carl Sagan, Pale Blue Dot, a vision of the human future in space. Wanderers, an introduction. But tell me, who are they, these wanderers? Asked Rainer Maria Rilke. We were wanderers from the beginning. We knew every stand of tree for 100 miles. When the fruits or nuts were ripe, we were there. We followed the herds in their annual migrations. We rejoiced in fresh meat. Through stealth, feint, ambush, and main force assault, a few of us cooperating accomplished what many of us, each hunting alone, could not. We depended on one another. Making it on our own was as ludicrous to imagine as was settling down. Working together, we protected our children from the lions and the hyenas. We taught them the skills they would need and the tools. Then, as now, technology was the key to our survival. When the drought was prolonged, or when an unsettling chill lingered in the summer air, our group moved on, sometimes to unknown lands. We sought a better place. And when we couldn't get on with the others in our little nomadic band, we left to find a more friendly bunch somewhere else. We could always begin again. For 99.9% of the time since our species came to be, we were hunters and foragers, wanderers on the savannas and the steppes. There were no border guards then, no customs officials. The frontier was everywhere. We were bounded only by the earth and the ocean and the sky, plus occasional grumpy neighbors. When the climate was congenial, though, when the food was plentiful, we were willing to stay put. Unadventurous, overweight, careless. In the last 10,000 years, an instant in our long history, we've abandoned the nomadic life. We've domesticated the plants and animals. Why chase the food when you can make it come to you? For all its material advantages, the sedentary life has left us edgy, unfulfilled. Even after 400 generations in villages and cities, we haven't forgotten. The open road still softly calls, like a nearly forgotten song of childhood. We invest far-off places with a certain romance. The appeal, I suspect, has been meticulously crafted by natural selection as an essential element in our survival. Long summers, mild winters, rich harvests, plentiful game. None of them lasts forever. It is beyond our powers to predict the future. Catastrophic events have a way of sneaking up on us, of catching us unaware. Your own life, or your band's, or even your species might be owed to a restless few drawn by a craving they can hardly articulate or understand, to undiscovered lands and new worlds. Herman Melville in Moby Dick spoke for wanderers in all epochs and meridians. He said, "I am tormented with an everlasting itch for things remote. I love to sail forbidden seas." To the ancient Greeks and Romans, the known world comprised Europe and an attenuated Asia and Africa, all surrounded by an impassable world ocean. Travelers might encounter inferior beings called barbarians, or superior beings called gods. Every tree had its dryad, every district its legendary hero. But there were not very many gods, at least at first, perhaps only a few dozen. They lived on mountains, under the earth, in the sea, or up there in the sky. They sent messages to people, intervened in human affairs, and interbred with us. As time passed, as the human exploratory capacity hit its stride, there were surprises. Barbarians could be fully as clever as Greeks and Romans. Africa and Asia larger than anyone had guessed. the world ocean was not impassable. There were antipodes. 3 new continents existed, had been settled by Asians in ages past, and the news had never reached Europe. Also, the gods were disappointingly hard to find. The first large-scale human migration from the Old World to the New happened during the last ice age, about 11,500 years ago, when the growing polar ice caps shallowed the oceans and made it possible to walk on dry land from Siberia to Alaska. 1,000 years later, we were in Tierra del Fuego, the southern tip of South America. Long before Columbus, Indonesian Argonauts in outrigger canoes explored the western Pacific. People from Borneo settled Madagascar. Egyptians and Libyans circumnavigated Africa. And a great fleet of ocean-going junks from Ming Dynasty China crisscrossed the Indian Ocean, established a base in Zanzibar, rounded the Cape of Good Hope, and entered the Atlantic Ocean. In the 15th through 17th centuries, European sailing ships discovered new continents, new at any rate to Europeans, and circumnavigated the planet. In the 18th and 19th centuries, American and Russian explorers, traders, and settlers raced west and east across 2 vast continents to the Pacific. This zest to explore and exploit, however thoughtless its agents may have been, has clear survival value. It is not restricted to any one nation or ethnic group. It is an endowment that all members of the human species hold in common. Since we first emerged a few million years ago in East Africa, we've meandered our way around the planet. There are now people on every continent and the remotest islands, from pole to pole, from Mount Everest to the Dead Sea, on the ocean bottoms, and even, occasionally, in residence 200 miles up. Humans, like the gods of old, living in the sky. These days, there seems to be nowhere left to explore, at least on the land area of the Earth. Victims of their very success, the explorers now pretty much stay home. Vast migrations of people, some voluntary, most not, have shaped the human condition. More of us flee from war, oppression, and famine today than at any other time in human history. As the Earth's climate changes in the coming decades, there are likely to be far greater numbers of environmental refugees. Better places will always call to us. Tides of people will continue to ebb and flow across the planet. But the lands we run to now have already been settled. Other people, often unsympathetic to our plight, are there before us. Late in the 19th century, Leib Gruber was growing up in Central Europe, in an obscure town in the immense, polyglot, ancient Austro-Hungarian Empire. His father sold fish when he could, but times were often hard. As a young man, the only honest employment Leib could find was carrying people across the nearby river Bug. The customer, male or female, would mount on Leib's back. In his prized boots, the tools of his trade, he would wade out in a shallow stretch of the river and deliver his passenger to the opposite bank. Sometimes the water reached his waist. There were no bridges here, no ferry boats. Horses might have served the purpose, but they had other uses. That left Leib and a few other young men like him. They had no other uses. No other work was available. They would lounge about the riverbank, calling out their prices, boasting to potential customers about the superiority of their drayage. They hired themselves out like four-footed animals. My grandfather was a beast of burden. I don't think that in all his young manhood, Leib had ventured more than 100 kilometers from his little hometown of Sasov. But then, in 1904, he suddenly ran away to the New World. To avoid a murder rap, according to one family legend, he left his young wife behind. How different from his tiny backwater hamlet the great German port cities must have seemed. How vast the ocean. How strange the lofty skyscrapers and endless hubbub of his new land. We know nothing of his crossing, but have found the ship's manifest for the journey undertaken later by his wife Chaya, joining Leib after he had saved enough to bring her over. She traveled in the cheapest class on the Batavia, a vessel of Hamburg registry. There's something heartbreakingly terse about the document. Can she read or write? No. Can she speak English? No. How much money does she have? I can imagine her vulnerability and her shame as she replies, $1. She disembarked in New York, was reunited with Leib, lived just long enough to give birth to my mother and her sister, and then died from complications of childbirth. In those few years in America, her name had sometimes been anglicized to Clara. A quarter century later, my mother named her own firstborn a son, after the mother she never knew. Our distant ancestors, watching the stars, noted 5 that did more than just rise and set in stolid procession as the so-called fixed stars did. These 5 had a curious and complex motion. Over the months they seemed to wander slowly among the stars. Sometimes they did loops. Today we call them planets, the Greek word for wanderers. It was, I imagine, a peculiarity our ancestors could relate to. We know now that the planets are not stars, but other worlds, gravitationally lashed to the sun. Just as the exploration of the Earth was being completed, we began to recognize it as one world among an uncounted multitude of others, circling the sun or orbiting the other stars that make up the Milky Way galaxy. Our planet and our solar system are surrounded by a new world ocean, the depths of space. It is no more impassable than the last. Maybe it's a little early. Maybe the time is not quite yet. But those other worlds, promising untold opportunities, beckon. In the last few decades, the United States and the former Soviet Union have accomplished something stunning and historic: the close-up examination of all those points of light, from Mercury to Saturn, that moved our ancestors to wonder and to science. Since the advent of successful interplanetary flight in 1962, our machines have flown by, or orbited, or landed on more than 70 new worlds. We have wandered among the wanderers. We have found vast volcanic eminences that dwarf the highest mountain on Earth, ancient river valleys on 2 planets, enigmatically one too cold and the other too hot for running water, a giant planet with an interior of liquid metallic hydrogen into which 1,000 Earths would fit, whole moons that have melted, a cloud-covered place with an atmosphere of corrosive acids, where even the high plateaus are above the melting point of lead, ancient surfaces on which a faithful record of the violent formation of the solar system is engraved, refugee ice worlds from the trans-Plutonian depths, exquisitely patterned ring systems marking the subtle harmonies of gravity, and a world surrounded by clouds of complex organic molecules like those that in the earliest history of our planet led to the origin of life. Silently, they orbit the sun, waiting. We have uncovered wonders undreamt by our ancestors who first speculated on the nature of those wandering lights in the night sky. We have probed the origins of our planet and ourselves by discovering what else is possible, by coming face to face with alternative fates of worlds more or less like our own. We have begun to better understand the Earth. Every one of those worlds is lovely and instructive, but so far as we know, they are also, every one of them, desolate and barren. Out there are no better places, So far, at least. During the Viking robotic missions, beginning in July 1976, in a certain sense, I spent a year on Mars. I examined the boulders and sand dunes, the sky red even at high noon, the ancient river valleys, the soaring volcanic mountains, the fierce wind erosion, the laminated polar terrain, the two dark potato-shaped moons. But there was no life, not a cricket or a blade of grass, or even, so far as we can tell for sure, a microbe. These worlds have not been graced, as ours has, by life. Life is a comparative rarity. You can survey dozens of worlds and find that in only one of them does life arise and evolve and persist. Having in all their lives till then crossed nothing wider than a river, Leib and Chaya graduated to crossing oceans. They had one great advantage. On the other side of the waters there would be, invested with outlandish customs, it's true, other human beings, speaking their language and sharing at least some of their values, even people to whom they were closely related. In our time, we've the solar system and sent 4 ships to the stars. Neptune lies 1,000,000 times further from Earth than New York City is from the banks of the river Bug. But there are no distant relatives, no humans, and apparently no life waiting for us on those other worlds. No letters conveyed by recent emigres help us to understand the new land. Only digital data, transmitted at the speed of light by unfeeling, precise robot emissaries. They tell us that these new worlds are not much like home, but we continue to search for inhabitants. We can't help it. Life looks for life. No one on Earth, not the richest among us, can afford the passage. So we can't pick up and leave for Mars or Titan on a whim, or because we're bored or out of work or drafted into the army or oppressed, or because justly or unjustly we've been accused of a crime. There does not seem to be sufficient short-term profit to motivate private industry. If we humans ever go to those worlds, then it will be because a nation or a consortium of them believes it to be to its advantage, or to the advantage of the human species. Just now, there are a great many matters that are pressing in on us that compete for the money it takes to send people to other worlds. That's what this audiobook is about. Other worlds, what awaits us on them, and what they tell us about ourselves. And, given the urgent problems our species now faces, whether it makes sense to go. Should we solve those problems first, or are they a reason for going? This book is in many ways optimistic about the human prospect. The earliest chapters may at first sight seem to revel overmuch in our imperfections, but they lay an essential spiritual and logical foundation for the development of my argument. I've tried to present more than one facet of an issue. There will be places when I seem to be arguing with myself. I am. Seeing some merit to more than one side, I often argue with myself. I hope by the last chapter it will be clear where I come out. The plan of the book is roughly this. We first examine the widespread claims made over all of human history that our world and our species are unique and even central to the workings and purpose of the cosmos. We venture through the solar system in the footsteps of the latest voyages of exploration and discovery, and then assess the reasons commonly offered for sending humans into space. In the last and most speculative part of the book, I trace how I imagine that our long-term future in space will work itself out. Pale Blue Dot is about a new recognition, still slowly overtaking us, of our coordinates, our place in the universe, and how, even if the call of the open road is muted in our time, a central element of the human future lies far beyond the Earth. Chapter 1. You are here. The entire earth is but a point, and the place of our own habitation but a minute corner of it, said Marcus Aurelius, the Roman emperor, around 170. As the astronomers unanimously teach, the circuit of the whole earth, which to us seems endless, compared with the greatness of the universe, has the likeness of a mere tiny point, said Ammianus Marcellinus, the last major Roman historian. The spacecraft was a long way from home, beyond the orbit of the outermost planet and high above the ecliptic plane, which is an imaginary flat surface that we can think of as something like a racetrack in which the orbits of the planets are mainly confined. The ship speeding away from the sun at 40,000 miles an hour, but in early February of 1990, it was overtaken by an urgent message from Earth. Obediently, it turned its cameras back toward the now distant planets, slewing its scan platform from one spot in the sky to another. It snapped 60 pictures and stored them in digital form on its tape recorder. Then slowly, in March, April, and May, it radioed the data back to Earth. Each image was composed of 640,000 individual picture elements, or pixels, like the dots in a newspaper wire photo or a pointillist painting. The spacecraft was 3.7 billion miles away from Earth, so far away that it took each pixel 5.5 hours, traveling at the speed of light, to reach us. The pictures might have been returned earlier, but the big radio telescopes in California, Spain, and Australia that receive these whispers from the edge of the solar system had responsibilities to other ships that ply the sea of space, among them Magellan, bound for Venus, and Galileo on its tortuous passage to Jupiter. Voyager 1 was so high above the ecliptic plane because, in 1981, it had made a close pass by Titan, the giant moon of Saturn. Its sister ship, Voyager 2, was dispatched on a different trajectory, within the ecliptic plane, and so she was able to perform her celebrated explorations of Uranus and Neptune. The two Voyager robots have explored 4 planets and nearly 60 moons. They are triumphs of human engineering and one of the glories of the American space program. They will be in the history books when much else about our time is forgotten. The Voyagers were guaranteed to work only until the Saturn encounter. I thought it might be a good idea, just after Saturn, to have them take one last glance homeward. From Saturn, I knew, the Earth would appear too small for Voyager to make out any detail. Our planet would be just a point of light, a lonely pixel, hardly distinguishable from the many other points of light Voyager would see, nearby planets, far-off suns. But precisely because of the obscurity of our world thus revealed, such a picture might be worth having. Mariners had painstakingly mapped the coastlines of the continents. Geographers had translated these findings into charts and globes. Photographs of tiny patches of the Earth had been obtained first by balloons and aircraft, then by rockets in brief ballistic flight, and at last by orbiting spacecraft, giving a perspective like the one you achieve by positioning your eyeball about an inch above a large globe. While almost everyone is taught that the Earth is a sphere, with all of us somehow glued to it by gravity, the reality of our circumstance did not really begin to sink in until the famous frame-filling Apollo photograph of the whole Earth, the one taken by the Apollo 17 astronauts on the last journey of humans to the moon. It has become a kind of icon of our age. There's Antarctica at what Americans and Europeans so readily regard as the bottom, and then all of Africa stretching up above it. You can see Ethiopia, Tanzania, and Kenya, where the earliest humans lived. At top right are Saudi Arabia and what Europeans call the Near East. Just barely peeking out at the top is the Mediterranean Sea, around which so much of our global civilization emerged. You can make out the blue of the ocean, the yellow-red of the Sahara and the Arabian desert, the brown-green of forest and grassland. And yet, there is no sign of humans in this picture. Not our reworking of the Earth's surface, not our machines, not ourselves. We are too small, and our statecraft is too feeble to be seen by a spacecraft between the Earth and the Moon. From this vantage point, our obsession with nationalism is nowhere in evidence. The Apollo pictures of the whole Earth conveyed to multitudes something well known to astronomers. On the scale of worlds, to say nothing of stars or galaxies, humans are inconsequential, a thin film of life on an obscure and solitary lump of rock and metal. It seemed to me that another picture of the Earth, this one taken from 100,000 times farther away, might help in the continuing process of revealing to ourselves our true circumstance and condition. It had been well understood by the scientists and philosophers of classical antiquity that the Earth was a mere point in a vast, encompassing cosmos. But no one had ever seen it as such. Here was our first chance, and perhaps also our last, for decades to come. Many in NASA's Voyager project were supportive, but from the outer solar system, the Earth lies very near the Sun, like a moth enthralled around a flame. Did we want to aim the camera so close to the Sun as to risk burning out the spacecraft's Vidicon system? Wouldn't it be better to delay until all the scientific images from Uranus and Neptune, if the spacecraft lasted that long, were taken? And so we waited. And a good thing, too. From 1981 at Saturn, to 1986 at Uranus, to 1989, when both spacecraft had passed the orbits of Neptune and Pluto. At last, the time came. But there were a few instrumental calibrations that needed to be done first, and we waited a little longer. Although the spacecraft were in the right spots, the instruments were still working beautifully, and there were no other pictures to take, a few project personnel opposed it. It wasn't science, they said. Then we discovered that the technicians who devise and transmit the radio commands to Voyager were, in a cash-strapped NASA, to be laid off immediately or transferred to other jobs. If the picture were to be taken, it had to be done right then, at the last minute, actually in the midst of the Voyager 2 encounter with Neptune. The then NASA administrator, Rear Admiral Richard Truly, stepped in and made sure that these images were obtained. The space scientists Candy Hansen of NASA's Jet Propulsion Laboratory, JPL, and Carolyn Porco of the University of Arizona designed the command sequence and calculated the camera exposure times. So here they are, a mosaic of squares laid down on top of the planets, and a background smattering of more distant stars. We were able to photograph not only the Earth, but also 5 other of the Sun's 9 known planets. Mercury, the innermost, was lost in the glare of the Sun, and Mars and Pluto were too small, too dimly lit, and/or too far away. Uranus and Neptune are so dim that to record their presence required long exposures, and accordingly their images were smeared because of spacecraft motion. This is how the planets would look to an alien spaceship approaching the solar system after a long interstellar voyage. From this distance, the planets seem only points of light, smeared or unsmeared, even through the high-resolution telescope aboard Voyager. They are like the planets seen with the naked eye from the surface of the Earth, luminous dots, brighter than most of the stars. Over a period of months, the Earth, like the other planets, would seem to move among the stars. You cannot tell merely by looking at one of these dots what it's like, what's on it, what its past has been, and whether, in this particular epoch, anyone lives there. Because of the reflection of sunlight off the spacecraft, the Earth seems to be sitting in a beam of light, as if there was some special significance to this small world. But it's just an accident of geometry and optics. The sun emits its radiation equitably in all directions. Had the picture been taken a little earlier or a little later, there would have been no sunbeam highlighting the Earth. And why that cerulean color? The blue comes partly from the sea, partly from the sky. While water in a glass is transparent, it absorbs slightly more red light than blue. If you have tens of meters of the stuff or more, the red light is absorbed out, and what gets reflected back to space is mainly blue. In the same way, a short line of sight through air seems perfectly transparent. Nevertheless, something Leonardo da Vinci excelled in portraying, the more distant the object, the bluer it seems. Why? Because the air scatters blue light around much better than it does red. So the bluish cast of this dot comes from its thick but transparent atmosphere and its deep oceans of liquid water. And the white? The Earth on an average day is about half covered with white water clouds. We can explain the wan blueness of this little world because we know it well. Whether an alien scientist newly arrived at the outskirts of our solar system could reliably deduce oceans and clouds in a thickish atmosphere is less certain. Neptune, for instance, is blue, but chiefly for different reasons. From this distant vantage point, the Earth might not seem of any particular interest. But for us, it's different. Consider again that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. Chapter 2. Aberrations of Light. If man were taken away from the world, the rest would seem to be all astray, without aim or purpose, and to be leading to nothing, said Francis Bacon in 1619. Andrienne suggests an experiment. Consider again that pale blue dot we've been talking about. Imagine that you take a good long look at it. Imagine you're staring at the dot for any length of time, and then try to convince yourself that God created the whole universe for one of the 10 million or so species of life that inhabit that speck of dust. Now take it a step further. Imagine that everything was made just for a single shade of that species, or gender, or ethnic or religious subdivision. If this doesn't strike you as unlikely, pick another dot. Imagine it to be inhabited by a different form of intelligent life. They, too, cherish the notion of a God who has created everything for their benefit. How seriously do you take their claim? See that star? You mean the bright red one? His daughter asks in return. Yes, it might not be there anymore. It might be gone by now. Exploded or something. Its light is still crossing space, just reaching our eyes now. But we don't see it as it is. We see it as it was. Many people experience a stirring sense of wonder when they first confront this simple truth. Why? Why should it be so compelling? On our little world, light travels, for all practical purposes, instantaneously. If a light bulb is glowing, then, of course, it's physically where we see it, shining away. We reach out our hand and touch it. It's there all right, and unpleasantly hot. If the filament fails, then the light goes out. We don't see it in the same place, glowing, illuminating the room years after the bulb breaks and it's removed from its socket. The very notion seems nonsensical. But if we're far enough away, an entire sun can go out, and we'll continue to see it shining brightly. We won't learn of its death, it may be, for ages to come. In fact, for how long it takes light, which travels fast but not infinitely fast, to cross the intervening vastness. The immense distances to the stars and the galaxies mean that we see everything in space in the past. Some as they were before the Earth came to be. Telescopes are time machines. Long ago, when an early galaxy began to pour light out into the surrounding darkness, no witness could have known that billions of years later, some remote clumps of rock and metal, ice and organic molecules, would fall together to make a place called Earth, or that life would arise and thinking beings evolve, who would one day capture a little of that galactic light and try to puzzle out what had sent it on its way. And after the Earth dies, some 5 billion years from now, after it is burned to a crisp or even swallowed by the sun, there will be other worlds and stars and galaxies coming into being, and they will know nothing of a place once called Earth. It almost never feels like prejudice. Instead, it seems fitting and just. The idea that, because of an accident of birth, our group, whichever one it is, should have a central position in the social universe. Among pharaonic princelings and Plantagenet pretenders, children of robber barons and Central Committee bureaucrats, street gangs and conquerors of nations, members of confident majorities, obscure sects, and reviled minorities, this self-serving attitude seems as natural as breathing. It draws sustenance from the same psychic wellsprings as sexism, racism, nationalism, and the other deadly chauvinisms that plague our species. Uncommon strength of character is needed to resist the blandishments of those who assure us that we have an obvious, even God-given superiority over our fellows. The more precarious our self-esteem, the greater our vulnerability to such appeals. Since scientists are people, it's not surprising that comparable pretensions have insinuated themselves into the scientific worldview. Indeed, many of the central debates in the history of science seem to be, in part at least, contests over whether humans are special. Almost always the going-in assumption is that we are special. After the premise is closely examined, though, it turns out, in dishearteningly many cases, that we are not. Our ancestors lived out of doors. They were as familiar with the night sky as most of us are with our favorite television programs. The sun, the moon, the stars, and the planets all rose in the east and set in the west, traversing the sky overhead in the interim. The motion of the heavenly bodies was not merely a diversion, eliciting a reverential nod and grunt. It was the only way to tell the time of day and the seasons. For hunters and gatherers, as well as for agricultural peoples, knowing about the sky was a matter of life and death. How lucky for us that the sun, the moon, the planets, and the stars are part of some elegantly configured cosmic clockwork. It seemed to be no accident. They were put here for a purpose, for our benefit. Who else makes use of them? What else are they good for? And if the lights in the sky rise and set around us, isn't it evident that we're at the center of the universe? These celestial bodies, so clearly suffused with unearthly powers, especially the sun, on which we depend for light and heat, circle us like courtiers fawning on a king. Even if we had not already guessed, the most elementary examination of the heavens reveals that we are special. The universe seems designed for human beings. It's difficult to contemplate these circumstances without experiencing stirrings of pride and reassurance. The entire universe made for us. We must really be something. This satisfying demonstration of our importance, buttressed by daily observations of the heavens, made the geocentrist conceit a transcultural truth. Taught in the schools, built into the language, part and parcel of great literature and sacred scripture. Dissenters were discouraged, sometimes with torture and death. It is no wonder that for the vast bulk of human history, no one questioned it. It was doubtless the view of our foraging and hunting ancestors. The great astronomer of antiquity, Claudius Ptolemy, in the 2nd century, knew that the earth was a sphere, knew that its size was a point compared to the distance of the stars, and taught that it, quote, lay right in the middle of the heavens, close quote. Aristotle, Plato, St. Augustine, St. Thomas Aquinas, and almost all the great philosophers and scientists of all cultures over the 3,000 years ending in the 17th century bought into this delusion. Some busied themselves figuring out how the sun, the moon, the stars, and the planets could be cunningly attached to perfectly transparent crystalline spheres, the big spheres, of course, centered on the earth, that would explain the complex motions of the celestial bodies so meticulously chronicled by generations of astronomers. And they succeeded. With later modifications, the geocentric hypothesis adequately accounted for the facts of planetary motion as known in the 2nd century and in the 16th. From there, it was only a slight extrapolation to an even more grandiose claim that the perfection of the world would be incomplete without humans, as Plato asserted in the Timaeus. Man is all, the poet and cleric John Donne wrote in 1625. He is not a piece of the world, but the world itself, and next to the glory of God, the reason why there is a world, said John Donne. And yet, Never mind how many kings, popes, philosophers, scientists, and poets insisted on the contrary. The Earth, through those millennia, stubbornly persisted in orbiting the sun. You might imagine an uncharitable extraterrestrial observer looking down on our species over all that time, with us excitedly chattering, "The universe created for us, we're at the center, everything pays homage to us," and concluding that our pretensions are amusing, our aspirations pathetic, that this must be the planet of the idiots. But such a judgment is too harsh. We did the best we could. There was an unlucky coincidence between everyday appearances and our secret hopes. We tend not to be especially critical when presented with evidence that seems to confirm our prejudices. And there was little countervailing evidence. In muted counterpoint, a few dissenting voices counseling humility and perspective could be heard down through the centuries. At the dawn of science, the atomist philosophers of ancient Greece and Rome, those who first suggested that matter is made of atoms, Democritus, Epicurus, and their followers, and Lucretius, the first popularizer of science, they scandalously proposed many worlds and many alien life forms, all made of the same kinds of atoms as we. They offered for our consideration infinities in space and time. But in the prevailing canons of the West, secular and sacerdotal, pagan and Christian, atomist ideas were reviled. Instead, the heavens were not at all like our world. They were unalterable and perfect. The earth was mutable and corrupt. The Roman statesman and philosopher Cicero summarized the common view. In the heavens, he said, there is nothing of chance or hazard, no error, no frustration, but absolute order, accuracy, calculation, and regularity. Close quote. Philosophy and religion cautioned that the gods, or God, were far more powerful than we, jealous of their prerogatives, and quick to mete out justice for insufferable arrogance. At the same time, these disciplines had not a clue that their own teaching of how the universe is ordered was a conceit and a delusion. Philosophy and religion presented mere opinions, opinion that might be overturned by observation and experiment as certainty. This worried them not at all. That some of their deeply held beliefs might turn out to be mistakes was a possibility hardly considered. Doctrinal humility was to be practiced by others. Their own teachings were inerrant and infallible. In truth, they had better reason to be humble than they knew. Beginning with Copernicus in the middle 16th century, the issue was formally joined. The picture of the sun rather than the earth at the center of the universe was understood to be dangerous. Obligingly, many scholars were quick to assure the religious hierarchy that this newfangled hypothesis represented no serious challenge to conventional wisdom. In a kind of split-brain compromise, the sun-centered system was treated as a mere computational convenience, not an astronomical reality. That is, the Earth was really at the center of the universe, as everybody knew, but if you wished to predict where Jupiter would be on the second Tuesday of November the year after next, you were permitted to pretend that the sun was at the center. Then you could calculate away and not affront the authorities. "This has no danger in it," wrote Robert Cardinal Bellarmine, the foremost Vatican theologian in the early 17th century. "And suffices," he continued, "for the mathematicians. But to affirm that the sun is really fixed at the center of the heavens, and that the earth revolves very swiftly around the sun, is a dangerous thing," Cardinal Bellarmine went on, "not only irritating the theologians and philosophers, but injuring our holy faith and making the sacred scripture false." "Freedom of belief is pernicious," Bellarmine wrote on another occasion. "It is nothing but the freedom to be wrong." Besides, if the Earth was going around the Sun, nearby stars should seem to move against the background of more distant stars, as every 6 months we shift our perspective from one side of the Earth's orbit to the other. No such annual parallax had been found. The Copernicans argued that this was because the stars were extremely far away, maybe 1,000,000 times more distant than the Earth is from the Sun. Perhaps better telescopes in future times would find an annual parallax. The geocentrists considered this a desperate attempt to save a flawed hypothesis, and ludicrous on the face of it. When Galileo turned the first astronomical telescope to the sky, the tide began to turn. He discovered that Jupiter had a little retinue of moons circling it, the inner ones orbiting faster than the outer ones, just as Copernicus had deduced for the motion of the planets around the Sun. He found that Mercury and Venus went through phases like the Moon, showing they orbited the Sun. Moreover, the cratered Moon and the spotted Sun challenged the perfection of the heavens. This may in part constitute the sort of trouble Tertullian was worried about 1,300 years earlier, when he pleaded, quote, "If you have any sense or modesty, have done with prying into the regions of the sky, into the destiny and secrets of the universe," close quote. In contrast, Galileo taught that we can interrogate nature by observation and experiments. Then, quote, "facts which at first sight seem improbable will, even on scant explanation, drop the cloak which had hidden them, and stand forth in naked and simple beauty," close quote. Are not these facts, available even for skeptics to confirm, a surer insight into God's universe than all the speculation of the theologians? But what if these facts contradict the beliefs of those who hold their religion incapable of making mistakes? The princes of the church threatened the aged astronomer with torture if he persisted in teaching the abominable doctrine that the earth moved. He was sentenced to a kind of house arrest for the remainder of his life. A generation or two later, by the time Isaac Newton demonstrated that simple and elegant physics could quantitatively explain and predict all the observed lunar and planetary motions, provided you assume the sun at the center of the solar system, the geocentrist conceit eroded further. In 1725, in an attempt to discover stellar parallax, the painstaking English amateur astronomer James Bradley stumbled on the aberration of light. The term aberration, I suppose, conveys something of the unexpectedness of the discovery. When observed over the course of a year, stars were found to trace little ellipses against the sky. But all the stars were found to do so. This could not be stellar parallax, where we would expect a big parallax for nearby stars and an indetectable one for faraway stars. Instead, aberration is similar to how raindrops falling directly down on a speeding auto seem to the passengers to be falling at a slant. The faster the car goes, the steeper the slant. If the Earth was stationary at the center of the universe and not speeding in its orbit around the Sun, Bradley would not have found the aberration of light. It was a compelling demonstration that the Earth revolved about the Sun. It convinced most astronomers and some others, but not, Bradley thought, the anti-Copernicans. But not until 1837 did direct observations of the stars prove in the clearest way that the Earth is indeed circling the Sun. The long-debated annual parallax was at last discovered, not by better arguments, but by better instruments. Because explaining what it means is much more straightforward than explaining the aberration of light, its discovery was very important. It pounded the final nail into the coffin of geocentrism. You need only look at your finger with your left eye, and then with your right, and see it seem to move. Everybody can understand parallax. By the 19th century, all scientific geocentrists had been converted or rendered extinct. Once most scientists had been convinced, informed public opinion had swiftly changed, in some countries in a mere 3 or 4 generations. Of course, in the time of Galileo and Newton, and even much later, there were still some who objected. who tried to prevent the new sun-centered universe from becoming accepted or even known. And there were many who at least harbored secret reservations. By the late 20th century, just in case there were any holdouts, we've been able to settle the matter directly. We've been able to test whether we live in an Earth-centered system with planets affixed to transparent crystal spheres, or in a sun-centered system with planets controlled at a distance by the gravity of the sun. We have, for example, probed the planets with radar. When we bounce a signal off a moon of Saturn, we receive no radio echo from a nearer crystal sphere attached to Jupiter. Our spacecraft arrive at their appointed destinations with astonishing precision, exactly as predicted by Newtonian gravitation. When our ships fly to Mars, say, their instruments do not hear a tinkling sound or detect shards of broken crystal as they crash through the spheres that, according to the authoritative opinions that prevailed for millennia, propel Venus or the Sun in their dutiful motions about the central Earth. When Voyager 2 scanned the solar system from beyond the outermost planet, it saw, just as Copernicus and Galileo had said we would, the Sun in the middle, and the planets in concentric orbits about it. Far from being the center of the universe, the Earth is just one of the orbiting dots. No longer confined to a single world, we are now able to reach out to others and determine decisively what kind of planetary system we inhabit. Every other proposal, and their number is legion, to displace us from cosmic center stage has also been resisted, in part for similar reasons. We seem to crave privilege, merited not by our works, but by our birth, by the mere fact that, say, we're humans and born on Earth. We might call it the anthropocentric, the human-centered conceit. This conceit is brought close to culmination in the notion that we are created in God's image. The creator and ruler of the entire universe looks just like me. My, what a coincidence. How convenient and satisfying. The 6th century BC Greek philosopher Xenophanes understood the arrogance of this perspective. Here's what he said. The Ethiopians make their gods black and snub-nosed. The Thracians say theirs have blue eyes and red hair. Yes, and if oxen and horses or lions had hands, and could paint with their hands, and produce works of art as men do, horses would paint the forms of the gods like horses, and oxen like oxen. Such attitudes were once described as provincial, the naive expectation that the political hierarchies and social conventions of an obscure province extend to a vast empire composed of many different traditions and cultures, that the familiar boondocks, our boondocks, are the center of the world. The country bumpkins know almost nothing about what else is possible. They fail to grasp the insignificance of their province or the diversity of the empire. With ease, they apply their own standards and customs to the rest of the planet. But plop down in Vienna, say, or Hamburg or New York, ruefully they recognize how limited their perspective has been. They become deprovincialized. Modern science has been a voyage into the unknown, with a lesson in humility waiting at every stop. Many passengers would rather have stayed home. Chapter 3. The Great Demotions. One philosopher asserted that he knew the whole secret. He surveyed the two celestial strangers from top to toe, and maintained to their faces that their persons, their worlds, their suns and their stars were created solely for the use of man. At this assertion, our two travelers let themselves fall against each other, seized with a fit of inextinguishable laughter. That's from Voltaire's Micromegas in 1752. In the 17th century, there was still some hope that even if the Earth was not the center of the universe, it might be the only world. but Galileo's telescope revealed that, quote, "the moon certainly does not possess a smooth and polished surface," close quote, and that other worlds might look just like the face of the Earth itself. The moon and the planets showed unmistakably that they had as much claim to being worlds as the Earth does, with mountains, craters, atmospheres, polar ice caps, clouds, and, in the case of Saturn, a dazzling, unheard-of set of circumferential rings. After millennia of philosophical debate, the issue was settled decisively in favor of what was called the plurality of worlds. They might be profoundly different from our planet. None of them might be as congenial for life, but the Earth was hardly the only one. This was the next in the series of great demotions, downlifting experiences, demonstrations of our apparent insignificance, wounds that science has, in its search for Galileo's facts, delivered to human pride. Well, some hoped, even if the Earth isn't at the center of the universe, the Sun is. The Sun is our sun. So the Earth is approximately at the center of the universe. Perhaps some of our pride could in this way be salvaged. But by the 19th century, observational astronomy had made it clear that the Sun is but one lonely star in a great self-gravitating assemblage of suns called the Milky Way galaxy. Far from being at the center of the galaxy, our sun, with its entourage of dim and tiny planets, lies in an undistinguished sector of an obscure spiral arm. We are 30,000 light years from the center. Well, our Milky Way is the only galaxy. The Milky Way galaxy is in fact one of billions, perhaps hundreds of billions, of galaxies notable neither in mass, nor in brightness, nor in how its stars are configured and arrayed. Some modern deep sky photographs show more galaxies beyond the Milky Way than stars within the Milky Way. Every one of them is an island universe containing perhaps 100 billion suns. Such an image is a profound sermon on humility. Well then, at least our galaxy is at the center of the universe. Nope, this is wrong too. When the expansion of the universe was first discovered, many people naturally gravitated to the notion that the Milky Way was at the center of the expansion, and all the other galaxies running away from us. We now recognize that astronomers on any galaxy would see all the others running away from them. Unless they were very careful, they would all conclude that they were at the center of the universe. There is, in fact, no center to the expansion, no point of origin of the Big Bang, at least not in ordinary three-dimensional space. Well, even if there are hundreds of billions of galaxies, each with hundreds of billions of stars, no other star has planets. If there are no other planets beyond our solar system, perhaps there's no other life in the universe. Our uniqueness might then be saved. Since planets are small and feebly shine by reflected sunlight, they're hard to find. Although applicable technology is improving with breathtaking speed, even a giant world like Jupiter, orbiting the nearest star, Alpha Centauri, would still be difficult to detect. In our ignorance, the geocentrists find hope. There was once a scientific hypothesis, not just well received but prevailing, that supposed our solar system to have formed through the near collision of the ancient sun with another star. The gravitational tidal interaction pulled out tendrils of sun stuff that quickly condensed into planets. Since space is mostly empty, and near-stellar collisions most rare, it was concluded that few other planetary systems exist. Perhaps only one, around that other star that long ago co-parented the worlds of our solar system. Early in my studies, I was amazed and disappointed that such a view had ever been taken seriously, that for planets of other stars, absence of evidence had been considered evidence of absence. Today, we have firm evidence for at least 3 planets orbiting an extremely dense star, the pulsar designated B1257+12, and we found for more than half the stars with masses like the Sun's that early in their careers they're surrounded by great disks of gas and dust, out of which planets seem to form. Other planetary systems now look to be a cosmic commonplace, maybe even world something like the Earth. We should be able in the next few decades to inventory at least the largest planets, if they exist, of hundreds of nearby stars. Well, if our position in space doesn't reveal our special role, our position in time does. We've been in the universe since the beginning, give or take a few days. We've been given special responsibilities by the Creator. It once seemed very reasonable to think of the universe as beginning just a little before our collective memory is obscured by the passage of time, and also the illiteracy of our ancestors. Generally speaking, that's hundreds or maybe thousands of years ago. Religions that purport to describe the origin of the universe often specify, implicitly or explicitly, a date of origin of roughly such vintage, a birthday for the world. If you add up all the begats in the book of Genesis, for example, you get an age for the Earth, 6,000 years old, plus or minus a little. The universe is said to be exactly as old as the Earth. This is still the standard of Jewish, Christian, and Muslim fundamentalists, and is clearly reflected in the Jewish calendar. But so young a universe raises an awkward question. How is it that there are astronomical objects more than 6,000 light years away? It takes light a year to travel a light year, 10,000 years to travel 10,000 light years, and so on. When we look at the center of the Milky Way galaxy, the light we see left its source some 30,000 years ago. The nearest spiral galaxy like our own, M31 in the constellation Andromeda, is 2 million light years away. So we're seeing it as it was when the light from it set out on its long journey to Earth 2 million years ago. And when we observe distant quasars 5 billion light years away, we're seeing them as they were 5 billion years ago before the Earth was formed. They are almost certainly very different today. So if, despite this, we were to accept the literal truth of such religious books, how could we reconcile the data? The only plausible conclusion, I think, is that God recently made all the photons of light arriving on the Earth in such a coherent format as to mislead generations of astronomers into the misapprehension that there are such things as galaxies and quasars, and intentionally driving them to the spurious conclusion that the universe is vast and old. This is such a malevolent theology, I still have difficulty believing that anyone, no matter how devoted to the divine inspiration of any religious book, could seriously entertain it. Beyond this, the radioactive dating of rocks, the abundance of impact craters on many worlds, the evolution of the stars, and the expansion of the universe each provides compelling and independent evidence that our universe is many billions of years old, despite the confident assertions of revered theologians that a world so old directly contradicts the Word of God, and that at any rate information on the antiquity of the world is inaccessible except to faith. These lines of evidence as well would have to be manufactured by a deceptive and malicious deity, unless the world is much older than the literalists in the Judeo-Christian Islamic religion suppose. Of course, no such problem arises for those many religious people who treat the Bible and the Quran as historical and moral guides and great literature, but who recognize that the perspective of these scriptures on the natural world reflects the rudimentary science of the time in which they were written. Ages rolled by before the earth began. More ages will run their course before it is destroyed. A distinction needs to be drawn between how old the earth is, around 4.5 billion years, and how old the universe is, about 15 billion years since the Big Bang. The immense interval of time between the origin of the universe and our epoch was 2/3 over before the earth came to be. Some stars and planetary systems are billions of years younger, others billions of years older. But in Genesis chapter 1, verse 1, the universe and the earth are created on the same day. The Hindu, Buddhist, Jain religion tends not to confound the two events. As for humans, we're latecomers. We appear in the last instant of cosmic time. The history of the universe till now was 99.998% over before our species arrived on the scene. In that vast sweep of eons, we could not have assumed any special responsibilities for our planet, or life, or anything else. We were not here. Well, if we can't find anything special about our position or our epoch, maybe there's something special about our motion. Newton and all the great classical physicists held that the velocity of the Earth in space constituted a privileged frame of reference. That's actually what it was called. Albert Einstein, a key critic of prejudice and privilege all his life, considered this absolute physics a remnant of an increasingly discredited Earth chauvinism. It seemed to him that the laws of nature must be the same no matter what the velocity or frame of reference of the observer. With this as his starting point, he developed the special theory of relativity. Its consequences are bizarre, counterintuitive. They grossly contradict common sense, but only at very high speeds. Careful and repeated observations show that his justly celebrated theory is an accurate description of how the world is made. Our common sense intuitions can be mistaken. Our preferences don't count. We do not live in a privileged reference frame. One consequence of special relativity is time dilation, the slowing down of time as the observer approaches light speed. You can still find claims that time dilation applies to watches and elementary particles, and presumably to circadian and other rhythms in plants, animals, and microbes, but not to human biological clocks. Our species has been granted, it is suggested, special immunity from the laws of nature, which must accordingly be able to distinguish deserving from undeserving collections of matter. In fact, the proof Einstein gave for special relativity admits no such distinctions. The idea of humans as exceptions to relativity seems just another incarnation of the notion of special creation. Special creation. Well, even if our position, our epoch, our motion, and our world are not unique, maybe we are. We're different from the other animals. We're specially created. The particular devotion of the creator of the universe is evident in us. This position was passionately defended on religious and other grounds. But in the middle 19th century, Charles Darwin showed convincingly how one species can evolve into another by entirely natural processes, which come down to the heartless business of nature saving the heredities that work and rejecting those that don't. Man, in his arrogance, thinks himself a great work, worthy of the interposition of a deity. Darwin wrote telegraphically in his notebook, "More humble, and I think truer, to consider him created from animals." Close quote. The profound and intimate connections of humans with the other life forms on Earth has been compellingly demonstrated in the late 20th century by the new science of molecular biology. In each age, the self-congratulatory chauvinisms are challenged in yet another arena of scientific debate. In this century, for example, in attempts to understand the nature of human sexuality, the existence of the unconscious mind, and the fact that many psychiatric illnesses and character defects have a molecular origin. But also, well, even if we're closely related to some of the other animals, we're different, not just in degree but in kind, on what really matters: reasoning, self-consciousness, tool-making, ethics, altruism, religion, language, nobility of character. While humans, like all animals, have traits that set them apart, Otherwise, how could we distinguish one species from another? Human uniqueness has been exaggerated, sometimes grossly so. Chimps reason, are self-conscious, make tools, show devotion, and so on. Chimps and humans have 99.6% of their active genes in common. Andrian and I run through the evidence in our book Shadows of Forgotten Ancestors. In popular culture, the very opposite position is also embraced, although it too is driven by human chauvinism, plus a failure of the imagination. Children's stories and cartoons make animals dress in clothes, live in houses, use knives and forks, and speak. The three bears sleep in beds. The owl and the pussycat go to sea in a beautiful pea-green boat. Dinosaur mothers cuddle their young. Pelicans deliver the mail. Dogs drive cars. A worm catches a thief. Pets have human names. Dolls, nutcrackers, cups and saucers dance and have opinions. The dish runs away with the spoon. In the Thomas the Tank Engine series, we even have anthropomorphic locomotives and railway cars charmingly portrayed. No matter what we're thinking about, animate or inanimate, we tend to invest it with human traits. We can't help ourselves. The images come readily to mind. Children are clearly fond of them. When we talk about a threatening sky, a troubled sea, diamonds resisting being scratched, the Earth attracting a passing asteroid, or an atom being excited, we are again drawn to a kind of animist worldview. We reify. Some ancient level of our thinking endows inanimate nature with life, passions, and forethought. The notion that the Earth is self-aware has lately been growing at the fringes of the Gaia hypothesis. But this was a commonplace belief of both the ancient Greeks and the early Christians. Origen wondered whether, quote, the Earth also, according to its own nature, is accountable for some sin, close quote. A host of ancient scholars thought the stars alive. This was also the position of Origen, of St. Ambrose, the mentor of St. Augustine, and even in a more qualified form of St. Thomas Aquinas. The Stoic philosophical position on the sun's nature was stated by Cicero in the 1st century BC, quote, since the sun resembles those fires which are contained in the bodies of living creatures, the sun must also be alive, close quote. Animist attitudes in general seem to have been spreading recently. In a 1954 American survey, 75% of people polled were willing to state that the sun is not alive. In 1989, though, only 30% would support so rash a proposition. On whether an automobile tire can feel anything, 90% of respondents denied it emotions in 1954, but only 73% in 1989. We can recognize here a shortcoming, in some circumstances serious, in our ability to understand the world. Characteristically, willy-nilly, we seem compelled to project our own nature onto nature. Although this may result in a consistently distorted view of the world, it does have one great virtue. Projection is the essential precondition for compassion. Okay, maybe we're not much. Maybe we're humiliatingly related to apes, but at least we're the best there is. God and angels aside, we're the only intelligent beings in the universe. One correspondent writes to me, quote, I am as sure of this as anything in my experience. There is no conscious life anywhere else in the universe. Mankind thus returns to its rightful position as center of the universe, close quote. However, partly through the influence of science and science fiction, most people today, in the United States at least, reject this proposition, for reasons I think essentially stated by the ancient Greek philosopher Chrysippus, who said, for any human being in existence to think that there is nothing in the whole world superior to himself would be an insane piece of arrogance, close quote. But the simple fact is that we have not yet found extraterrestrial life. We're in the earliest stages of looking, The question is wide open. If I had to guess, especially considering our long sequence of failed chauvinisms, I'd guess that the universe is filled with beings far more intelligent, far more advanced than we are. But of course, I might be wrong. Such a conclusion is at best based on a plausibility argument, derived from the numbers of planets, the ubiquity of organic matter, the immense timescales available for evolution, and so on. It's not a scientific demonstration. The question is among the most fascinating in all of science. We are just developing the tools to treat it seriously. What about the related matter of whether we are capable of creating intelligences smarter than ourselves? Computers routinely do mathematics that no unaided human can manage, outperform world champions in checkers and grandmasters in chess, speak and understand English and other languages, write presentable short stories and musical compositions, learn from their mistakes, and competently pilot ships, airplanes, and spacecraft. Their abilities steadily improve. They're getting smaller, faster, and cheaper. Every year, the tide of scientific advance laps a little further ashore on the island of human intellectual uniqueness with its embattled castaways. If, at so early a stage in our technological evolution, we have been able to go so far in creating intelligence out of silicon and metal, what will be possible in the following decades and centuries? What happens when smart machines are able to manufacture smarter machines? Perhaps the clearest indication that the search for an unmerited privileged position for humans will never be wholly abandoned is what in physics and astronomy is called the anthropic principle. It would be better named the anthropocentric principle. It comes in various forms. The weak anthropic principle merely notes that if the laws of nature and the physical constants, such as the speed of light, the electrical charge of the electron, the Newtonian gravitational constant, or Planck's quantum mechanical constant, if these had been different, the course of events leading to the origin of humans would never have transpired. Under other laws and constants, atoms would not hold together, or stars would evolve too quickly to leave sufficient time for life to evolve on nearby planets, or the chemical elements of which life is made would never have been generated, and so on. Different laws, no humans. There is no controversy about the weak anthropic principle. Change the laws and constants of nature, if you could, and a very different universe may emerge. In many cases, a universe incompatible with life. The mere fact that we exist implies, but does not impose, constraints on the laws of nature. By contrast, the various strong anthropic principles go much further. Some of their advocates come close to deducing that the laws of nature and the values of the physical constants were established, don't ask how or by whom, so that humans would eventually come to be. Almost all of the other possible universes, they say, are inhospitable. In this way, the ancient conceit that the universe was made for us is resuscitated. To me, it echoes Dr. Pangloss in Voltaire's Candide, convinced that this world, with all its imperfections, is the best possible. It sounds like playing my first hand of bridge, winning, knowing that there are 54 billion, that is 5.4 times 10 to the 28th, possible other hands that I was equally likely to have been dealt, and then foolishly concluding that a god of bridge exists, who favors me, a god who arranged the cards in the shuffle with my victory foreordained from the beginning. We do not know how many other winning hands there are in the cosmic deck, how many other kinds of universes, laws of nature, and physical constants that could also lead to life and intelligence, and perhaps even delusions of self-importance. Since we know next to nothing about how the universe was made, or even if it was made, it's difficult to pursue these matters productively. Voltaire asked, why is there anything? Einstein's formulation was to ask whether God had any choice in creating the universe. But if the universe is infinitely old, if the Big Bang some 15 billion years ago is only the most recent cusp in an infinite series of cosmic contractions and expansions, then it was never created, and the question of why it is as it is rendered meaningless. If, on the other hand, the universe has a finite age, why is it the way it is? Why wasn't it given a very different character? Which laws of nature go with which others? Are there meta-laws specifying the connections? Can we possibly discover them? Of all conceivable laws of gravity, say, which ones can exist simultaneously with which conceivable laws of quantum physics that determine the very existence of macroscopic matter? Are all laws we can think of possible? Or is there only a restricted number that can somehow be brought into existence? Clearly, we have not a glimmering of how to determine which laws of nature are possible and which are not. Nor do we have more than the most rudimentary notion of what correlation of natural laws are permitted. For example, Newton's universal law of gravitation specifies that the mutual gravitational force attracting two bodies towards each other is inversely proportional to the square of how far they are apart. You move twice as far from the center of the Earth, and you weigh a quarter as much. 10 times farther, and you weigh only 1/100th of your ordinary weight, and so on. It's this inverse square law that permits the exquisite circular and elliptical orbits of planets around the Sun, and moons around the planets, as well as the precision trajectory. Rather than an inverse square law, soon there would be no planets for living beings to inhabit. So, of all the possible gravitational force laws, why are we so lucky as to live in a universe sporting a law consistent with life? Well, first, of course, we're so lucky because if we weren't, we wouldn't be here to ask the question. It is no mystery that inquisitive beings who evolve on planets can be found only in universes that admit planets. Second, the inverse square law is not the only one consistent with stability over billions of years. Any power law less steep than 1 over r cubed, 1 over r to the 2.99 power, for example, or 1 over r, will keep a planet in the vicinity of a circular orbit, even if it's somehow given a shove. We have a tendency to overlook the possibility that other conceivable laws of nature might also be consistent with life. But there's a further point. It's not arbitrary that we have an inverse square law of gravitation. When Newton's theory is understood in terms of the more encompassing general theory of relativity, we recognize that the exponent of the gravity law is 2, because the number of physical dimensions we live in is 3. All gravity laws aren't available, free for a creator's choosing. Even given an infinite number of three-dimensional universes for some great god to tinker with, the gravity law would always have to be the law of the inverse square. Newtonian gravity, we might say, is not a contingent facet of our universe, but a necessary one. In general relativity, gravity is due to the dimensionality and curvature of space. When we talk about gravity, we're talking about local dimples in space-time. This is by no means obvious and even affronts common-sense notions. But when examined deeply, the ideas of gravity and mass are not separate matters, but ramifications of the underlying geometry of space-time. I wonder if something like this doesn't apply generally to all anthropic hypotheses. The laws or physical constants on which our lives depend turn out to be members of a class, perhaps even a vast class, of other laws and other physical constants. But some of these are also compatible with a kind of life. Often we do not, or cannot, work through what those other universes allow. Beyond that, not every arbitrary choice of a law of nature or a physical constant may be available even to a maker of universes. Our understanding of which laws of nature and which physical constants are up for grabs is fragmentary at best. Moreover, we have no access to any of those putative alternative universes. We have no experimental method by which anthropic hypotheses may be tested. Even if the existence of such universes were to follow firmly from well-established theories, of quantum mechanics or gravitation, say, we could not be sure that there weren't better theories that predict no alternative universes. Until that time comes, if it ever does, it seems to me premature to put faith in the anthropic principle as an argument for human centrality or uniqueness. Finally, even if the universe were intentionally created to allow for the emergence of life or intelligence, other beings may exist on countless worlds. If so, it would be cold comfort to anthropocentrists that we inhabit one of the few universes that allow life and intelligence. There's something stunningly narrow about how the anthropic principle is phrased. Yes, only certain laws and constants of nature are consistent with our kind of life, but essentially the same laws and constants are required to make a rock. So why not talk about a universe designed so rocks could one day come to be, and strong and weak lithic principles? If stones could philosophize, I imagine lithic principles would be at the intellectual frontiers. There are cosmological models being formulated today in which even the entire universe is nothing special. Andrei Lind, formerly of the Lebedev Physical Institute in Moscow and now at Stanford University, has incorporated current understanding of the strong and weak nuclear forces and quantum physics into a new cosmological model. Lind envisions a vast cosmos, much larger than our universe, perhaps extending literally to infinity, both in space and time. Not the paltry 15 billion light years or so in radius, and 15 billion years in age, which are the usual understanding. In this cosmos there is, as here, a kind of quantum fluff, in which tiny structures much smaller than an electron are everywhere forming, reshaping, and dissipating, in which, as here, fluctuations in absolutely empty space create pairs of elementary particles, an electron and a positron, for example. In the froth of quantum bubbles, the vast majority remain submicroscopic. But a tiny fraction inflate, grow, and achieve respectable universehood. They are so far away from us, though, much farther than the 15 billion light years that's the conventional scale of our universe, that if they exist, they appear to be wholly inaccessible and undetectable. Most of these other universes reach a maximum size and then collapse, contract to a point, and disappear forever. Others may oscillate. Still others may expand without limit. In different universes, there will be different laws of nature. We live, Lind argues, in one such universe, one in which the physics is congenial for growth, inflation, expansion, galaxies, stars, worlds, life. We imagine our universe to be unique, but it is one of an immense number, perhaps an infinite number, of equally valid, equally independent, equally isolated universes. There will be life in some, and not in others. In this view, the observable universe is just a newly formed backwater of a much vaster, infinitely old, and wholly unobservable cosmos. If something like this is right, even our residual pride, pallid as it must be, of living in the only universe, is denied to us. Maybe someday, despite current evidence, a means will be devised to peer into adjacent universes, sporting very different laws of nature, and we will see what else is possible. Or perhaps inhabitants of adjacent universes can peer into ours. Of course, in such speculations, we have far exceeded the bounds of knowledge. But if something like Lind's cosmos is true, there is, amazingly, still another devastating deprovincialization awaiting us. Our powers are far from adequate to be creating universes anytime soon. Strong anthropic principle ideas are not amenable to proof, although Lind's cosmology does have some testable features. Extraterrestrial life aside, if self-congratulatory pretensions to centrality have now retreated to such bastions impervious to experiment, then I'd say that the sequence of scientific battles with human chauvinism seemed to have been, at least largely, won. The long-standing view, as summarized by the philosopher Immanuel Kant, that without man, the whole of creation would be a mere wilderness, a thing in vain, and have no final end, is revealed to be self-indulgent folly. A principle of mediocrity seems to apply to all our circumstances. We would not have known beforehand that the evidence would be so repeatedly and thoroughly incompatible with the proposition that human beings are at center stage in the universe. But most of the debates have now been settled decisively in favor of a position that, however painful, can be encapsulated in a single sentence: we have not been given the lead in the cosmic drama. Perhaps someone else has. Perhaps no one else has. In either case, we have good reason for humility. Chapter 4. A universe not made for us. The sea of faith was once too at the full, and round earth's shore lay like the folds of a bright girdle furled. But now I only hear its melancholy, long withdrawing roar, retreating to the breath of the night wind down the vast edges drear and naked shingles of the world. That's from Matthew Arnold's Dover Beach, 1867. What a beautiful sunset, we say, or I'm up before sunrise. No matter what the scientists allege, in everyday speech we often ignore their findings. We don't talk about the earth turning, but about the sun rising and setting. Try formulating it in Copernican language. What would you say? Billy be home by the time the earth has rotated enough so as to occult the sun below the local horizon? Billy would be long gone before you're finished. We haven't been able even to find a graceful locution that accurately conveys the heliocentric insight. We at the center, and everything else circling us, is built into our languages. We teach it to our children. We are unreconstructed geocentrists, hiding behind a Copernican veneer. In 1633, the Roman Catholic Church condemned Galileo for teaching that the earth goes around the sun. Let's take a closer look at this famous controversy. In the preface to his book comparing the two hypotheses, an earth-centered and a sun-centered universe, Galileo had written these words: "The celestial phenomena will be examined, strengthening the Copernican hypothesis until it might seem that this must triumph absolutely." And later in the book he confessed, "Nor can I ever sufficiently admire Copernicus and his followers. They have, through sheer force of intellect, done such violence to their own senses as to prefer what reason told them over what sensible experience plainly showed them." The Church declared, in its indictment of Galileo, "The doctrine that the earth is neither the center of the universe nor immovable, but moves even with a daily rotation, is absurd, and both psychologically and theologically false, and at the least an error of faith." Galileo replied, "The doctrine of the movements of the earth and the fixity of the sun is condemned on the ground that the Scriptures speak in many places of the sun moving and the earth standing still. It is piously spoken that the Scriptures cannot lie, but none will deny that they are frequently abstruse and their true meaning difficult to discover, and more than the bare words signify. I think that in the discussion of natural problems, we ought to begin not with the Scriptures, but with experiments and demonstrations." But in his recantation on June 22, 1633, Galileo was made to say these words: having been admonished by the Holy Office entirely to abandon the false opinion that the sun was the center of the universe and immovable, and that the earth was not the center of the same, and that it moved, I have been suspected of heresy, that is, of having held and believed that the sun is the center of the universe and immovable, and that the earth is not the center of the same, and that it does move. I abjure with a sincere heart and unfeigned faith, I curse and detest the same errors and heresies, and generally all and every error and sect contrary to the Holy Catholic Church. It took the Church until 1832 to remove Galileo's work from its list of books which Catholics were forbidden to read at the risk of dire punishment of their immortal souls. Pontifical disquiet with modern science has ebbed and flowed since the time of Galileo. The high water mark in recent history is the 1864 Syllabus of Errors of Pius IX, the Pope who also convened the Vatican Council, at which the doctrine of papal infallibility was, at his insistence, first proclaimed. Here are a few excerpts from the Syllabus of Errors. Divine revelation is perfect, and therefore it is not subject to continual and indefinite progress in order to correspond with the progress of human reason. No man is free to embrace and profess that religion which he believes to be true, guided by the light of reason. The Church has power to define dogmatically the religion of the Catholic Church to be the only true religion. It is necessary even in the present day that the Catholic religion shall be held as the only religion of the state, to the exclusion of all other forms of worship. The civil liberty of every mode of worship, and full power given to all of openly and publicly manifesting their opinions and their ideas, conduce more easily to corrupt the morals and minds of the people. The Roman Pontiff cannot and ought not to reconcile himself or agree with progress, liberalism, and modern civilization. And so on. To its credit, although belatedly and reluctantly, the Church in 1992 repudiated its denunciation of Galileo. It still cannot quite bring itself, though, to see the significance of its opposition. In a 1992 speech, Pope John Paul II argued as follows. From the beginning of the Age of Enlightenment, he said, down to our own day, the Galileo case has been a sort of myth, in which the image fabricated out of the events is quite far removed from reality. In this perspective, the Galileo case was a symbol of the Catholic Church's supposed rejection of scientific progress, or of dogmatic obscurantism, opposed to the free search for truth. Close quote. But surely the Holy Inquisition, ushering the elderly and infirm Galileo in to inspect the instruments of torture in the dungeons of the Church, not only admits, but requires just such an interpretation. This was not mere scientific caution and restraint, a reluctance to shift the paradigm until compelling evidence, such as the annual parallax, was available. This was fear of discussion and debate, censoring alternative views and threatening to torture their proponents, betray a lack of faith in the very doctrine and parishioners that are ostensibly being protected. Why were threats and Galileo's house arrest needed? Cannot truth defend itself in its confrontation with error? The Pope does, though, go on to add, quote, the error of the theologians of the time, when they maintained the centrality of the earth, was to think that our understanding of the physical world structure was in some way imposed by the literal sense of sacred scriptures. Close quote. Here, indeed, considerable progress has been made, although proponents of fundamentalist faiths will be distressed to hear from the Pontiff that sacred scripture is not always literally true. But if the Bible is not everywhere literally true, which parts are divinely inspired and which are merely fallible and human? As soon as we admit that there are scriptural mistakes or concessions to the ignorance of the times, then how can the Bible be an inerrant guide to ethics and morals? Might sects and individuals now accept as authentic the parts of the Bible they like, and reject those that are inconvenient or burdensome? Prohibitions against murder, say, are essential for a society to function. But if divine retribution for murder is considered implausible, won't more people think they can get away with it? Many felt that Copernicus and Galileo were up to no good, and erosive of the social order. Indeed, any challenge from any source to the literal truth of the Bible might have such consequences. We can readily see how science began to make people nervous. Instead of criticizing those who perpetuated the myths, public rancor was directed at those who discredited them. Our ancestors understood origins by extrapolating from their own experience. How else could they have done it? So the universe was hatched from a cosmic egg, or conceived in the sexual congress of a mother god and a father god, or was a kind of product of the Creator's workshop, perhaps the latest of many flawed attempts. And the universe was not much bigger than we see, and not much older than our written or oral records, and nowhere very different from places that we know. We've tended in our cosmologies to make things familiar. Despite all our best efforts, we've not been very inventive. In the West, heaven is placid and fluffy, and hell is like the inside of a volcano. In many stories, both realms are governed by dominance hierarchies headed by gods or devils. Monotheists talked about the King of Kings. In every culture, we imagined something like our own political system running the universe. Few found the similarity suspicious. Then science came along and taught us that we are not the measure of all things, that there are wonders unimagined, that the universe is not obliged to conform to what was considered comfortable or plausible. We've learned something about the idiosyncratic nature of our common sense. Science has carried human self-consciousness to a higher level. This is surely a rite of passage, a step towards maturity. It contrasts starkly with the childishness and narcissism of our pre-Copernican notions. But why should we want to think that the universe was made for us? Why is the idea so appealing? Why do we nurture it? Is our self-esteem so precarious that nothing short of a universe custom-made for us will do? Of course it appeals to our vanity. What a man desires, he also imagines to be true, said Demosthenes. The light of faith makes us see what we believe, cheerfully admitted St. Thomas Aquinas. But I think there may be something else. There's a kind of ethnocentrism among primates. To whichever little group we happen to be born, we owe passionate love and loyalty. Members of other groups are beneath contempt, deserving of rejection and hostility. That both groups are of the same species, that to an outside observer they are virtually indistinguishable, makes no difference. This is certainly the pattern among the chimpanzees, our closest relatives in the animal kingdom. Andrian and I have described how this way of viewing the world may have made enormous evolutionary sense a few million years ago, however dangerous it has become today. Even members of hunter-gatherer groups, as far from the technological feats of our present global civilization as it's possible for humans to be, solemnly describe their little band, whichever it is, as the people. Everyone else is something different, something less than human. If this is our natural way of viewing the world, then it should occasion no surprise that every time we make a naive judgment about our place in the universe, one untempered by careful and skeptical scientific examination, we almost always opt for the centrality of our group and circumstance. We want to believe, moreover, that these are objective facts, and not our prejudices finding a sanctioned vent. So it's not much fun to have a gaggle of scientists incessantly haranguing us with, "You're ordinary, you're unimportant, your privileges are undeserved, there's nothing special about you." Even unexcitable people might after a while grow annoyed at this incantation, and those who insist on chanting it. It almost seems that the scientists are getting some weird satisfaction out of putting humans down. Why can't they find a way in which we're superior? Lift our spirits, exalt us. In such debates, science, with its mantra of discouragement, feels cold and remote, dispassionate, detached, unresponsive to human needs. And again, if we're not important, not central, not the apple of God's eye, what is implied for our theologically based moral codes? The discovery of our true bearings in the cosmos was resisted for so long and to such a degree that many traces of the debate remain, sometimes with the motives of the geocentrists laid bare. I want to read a revealing, unsigned commentary, more or less typical, in the British review The Spectator in 1892. Quote, "It is certain enough that the discovery of the heliocentric motion of the planets, which reduced our Earth to its proper insignificance in the solar system, did a good deal to reduce to a similar but far from proper insignificance the moral principles by which the predominant races of the Earth had hitherto been guided and restrained. Part of this effort was no doubt due to the evidence afforded that the physical science of various inspired writers was erroneous, instead of being infallible, a conviction which unduly shook the confidence felt even in their moral and religious teaching. But a good deal of it was due only to the mere sense of insignificance with which man has contemplated himself, since he has discovered that he inhabits nothing but a very obscure corner of the universe, instead of the central world around which sun, moon, and stars alike revolved. There can be no doubt that man may feel himself, and has often felt himself, a great deal too insignificant to be the object of any particular divine training or care. If the earth be regarded as a sort of anthill, and the life and death of human beings as the life and death of so many ants, which run into and out of so many holes in search of food and sunlight, it is quite certain that no adequate importance will be attached to the duties of human life, and that a profound fatalism and hopelessness, instead of new hopefulness, will attach to human effort. For the present, at least, the review concludes, our horizons are quite vast enough. Till we can get used to the infinite horizons we already have, and not lose our balance so much as we usually do in contemplating them, the yearning for still wider horizons is premature." So, what do we really want from philosophy and religion? Palliatives? Therapy? Comfort? Do we want reassuring fables, or an understanding of our actual circumstances? Dismay that the universe does not conform to our preferences seems childish. You might think that grown-ups would be ashamed to put such disappointments into print. The fashionable way of doing this is not to blame the universe, which seems truly pointless, but rather to blame the means by which we know the universe, namely, science. George Bernard Shaw, in the preface to his play St. Joan, described a sense of science preying on our credulity, forcing on us an alien worldview, intimidating belief. Quote, "In the Middle Ages, people believed that the earth was flat, for which they had at least the evidence of their senses. We believe it to be round not because as many as 1% of us could give the physical reason for so quaint a belief, but because modern science has convinced us that nothing that is obvious is true, and that everything that is magical, improbable, extraordinary, gigantic, microscopic, heartless, or outrageous is scientific." Close quote. A more recent and very instructive example is a book called Understanding the Present, Science and the Soul of Modern Man by Brian Appleyard, a British journalist. This book makes explicit what many people feel all over the world, but are too embarrassed to say. Appleyard's candor is refreshing. He is a true believer and will not let us slough over the contradictions between modern science and traditional religion. Science has taken away our religion, he laments. And what sort of religion is it that he longs for? One in which, quote, "the human race was the point, the heart, the final cause of the whole system. It placed ourselves definitely upon the universal map. We were the end, the purpose, the rational axle around which the great Etherian shells rotated. He longs for, quote, the universe of Catholic orthodoxy, in which, quote, the cosmos is shown to be a machine constructed around the drama of salvation, by which Appleyard means that despite explicit orders to the contrary, a woman and a man once ate of an apple, and that this act of insubordination transformed the universe into a contrivance for operant conditioning their remote descendants. By contrast, he says, modern science, quote, presents us as accidents. We are caused by the cosmos, but we are not the cause of it. Modern man is not finally anything. He has no role in creation, close quote. Science is, quote, spiritually corrosive, burning away ancient authorities and traditions. It cannot really coexist with anything. Science, quietly and inexplicitly, is talking us into abandoning ourselves, our true selves, close quote. It reveals, quote, the mute, alien spectacle of nature. Human beings cannot live with such a revelation. The only morality left is that of the consoling lie, close quote. Anything is better, he seems to be saying, than grappling with the unbearable burden of being tiny. In a passage reminiscent of Pius IX, Appleyard even decries the fact that, quote, a modern democracy can be expected to include a number of contradictory religious faiths, which are obliged to agree on a certain limited number of general injunctions, but no more. They must not burn each other's places of worship, but they may deny, even abuse each other's God. This is the effective scientific way of proceeding, close quote. But what is the alternative? Obdurately to pretend to certainty in an uncertain world? To adopt a comforting belief system, no matter how out of kilter with the facts it is? If we don't know what's real, how can we deal with reality? For practical reasons, we can't live too much in fantasy land. Shall we censor one another's religions and burn down one another's places of worship? How can we be sure which of the thousands of human belief systems should become unchallenged, ubiquitous, mandatory? These quotations betray a failure of nerve before the universe, its grandeur and magnificence, but especially its indifference. Science has taught us that because we have a talent for deceiving ourselves, subjectivity may not freely reign. This is one reason Appleyard so mistrusts science. It seems too reasoned, measured, and impersonal. Its conclusions derive from the interrogation of nature, and are not in all cases pre-designed to satisfy our wants. Appleyard deplores moderation. He yearns for inerrant doctrine, release from the exercise of judgment, and an obligation to believe but not to question. He has not grasped human fallibility. He recognizes no need to institutionalize error-correcting machinery, either in our social institutions or in our view of the universe. This is the anguished cry of the infant when the parent does not come. But most people eventually come to grips with reality and with the painful absence of parents who will absolutely guarantee that no harm befalls the little ones so long as they do what they're told. Eventually, most people find ways to accommodate to the universe, especially when given the tools to think straight. All that we pass on to our children in the scientific age, Appleyard complains, quote, is the conviction that nothing is true, final, or enduring, including the culture from which they sprang, close quote. How right he is about the inadequacy of our legacy. But would it be enriched by adding baseless certainties? He scorns, quote, the pious hope that science and religion are independent realms which can easily be separated, close quote. Instead, he says, quote, science, as it is now, is absolutely not compatible with religion, close quote. But isn't Appleyard really saying that some religions now find it difficult to make unchallenged pronouncements on the nature of the world that are straight out false? We recognize that even revered religious leaders, the products of their time, as we are of ours, may have made mistakes. Religions contradict one another on small matters such as whether we should put on a hat or take one off on entering a house of worship, or whether we should eat beef and eschew pork or the other way around, all the way to the most central issues such as whether there are no gods, one God, or many gods. Science has brought many of us to that state in which Nathaniel Hawthorne found Herman Melville. He can neither believe, Hawthorne said, nor be comfortable in his unbelief. Or Jean-Jacques Rousseau, quote, "They had not persuaded me, but they had troubled me. Their arguments had shaken me without ever convincing me. It is hard to prevent oneself from believing what one so keenly desires." Close quote. As the belief systems taught by the secular and religious authorities are undermined, respect for authority in general probably does erode. The lesson is clear. Even political leaders must be wary of embracing false doctrine. This is not a failing of science, but one of its graces. Of course, worldview consensus is comforting, while clashes of opinion may be unsettling and demand more of us. But unless we insist against all evidence that our ancestors were perfect, the advance of knowledge requires us to unravel and then restitch the consensus they established. In some respects, science has far surpassed religion in delivering awe. How is it that hardly any major religion has looked at science and concluded, this is better than we thought? The universe is much bigger than our prophets said, grander, more subtle, more elegant. God must be even greater than we dreamed. Instead, they say, no, my God is a little God, and I want him to stay that way. A religion old or new, that stressed the magnificence of the universe as revealed by modern science, might be able to draw forth reserves of reverence and awe hardly tapped by the conventional faiths. Sooner or later, such a religion will emerge. If you lived 2 or 3 millennia ago, there was no shame in holding that the universe was made for us. It was an appealing thesis consistent with everything we knew. It was what the most learned among us taught without qualification. But we've found out much since then. Defending such a position today amounts to willful disregard of the evidence and a flight from self-knowledge. Still, for many of us, these deep provincializations rankle. Even if they do not fully carry the day, they erode confidence. Unlike the happy anthropocentric certitudes rippling with social utility of an earlier age, we long to be here for a purpose, even though, despite much self-deception, none is evident. The meaningless absurdity of life, wrote Leo Tolstoy, is the only incontestable knowledge accessible to man. Close quote. Our time is burdened under the cumulative weight of successive debunkings of our conceits. We're Johnny-come-latelys. We live in the cosmic boondocks. We emerged from microbes and muck. Apes are our cousins. Our thoughts and feelings are not fully under our own control. There may be much smarter and very different beings elsewhere, and on top of all this, we're making a mess of our planet and becoming a danger to ourselves. The trapdoor beneath our feet swings open. We find ourselves in bottomless free fall. We are lost in a great darkness, and there's no one to send out a search party. Given so harsh a reality, of course we're tempted to shut our eyes and pretend that we're safe and snug at home, that the fall is only a bad dream. We lack consensus about our place in the universe. There is no generally agreed upon long-term vision of the goal of our species, other than, perhaps, simple survival. Especially when times are hard, we become desperate for encouragement, unreceptive to the litany of great demotions and dashed hopes, and much more willing to hear that we're special, never mind if the evidence is paper thin. If it takes a little myth and ritual to get us through a night that seems endless, who among us cannot sympathize and understand. But if our objective is deep knowledge rather than shallow reassurance, the gains from this new perspective far outweigh the losses. Once we overcome our fear of being tiny, we find ourselves on the threshold of a vast and awesome universe that utterly dwarfs, in time, in space, and in potential, the tidy anthropocentric proscenium of our ancestors. We gaze across billions of light years of space to view the universe shortly after the Big Bang and plumb the fine structure of matter. We peer down into the core of our planet and the blazing interior of our star. We read the genetic language in which is written the diverse skills and propensities of every being on Earth. We uncover hidden chapters in the record of our own origins, and with some anguish, better understand our nature and prospects. We invent and refine agriculture, without which almost all of us would starve to death. We create medicines and vaccines that save the lives of billions. We communicate at the speed of light and whip around the Earth in an hour and a half. We have sent dozens of ships to more than 70 worlds and 4 spacecraft to the stars. We are right to rejoice in our accomplishments, to be proud that our species has been able to see so far, and to judge our merit, in part, by the very science that has so deflated our pretensions. To our ancestors, there was much in nature to be afraid of: lightning, storms, earthquakes, volcanoes, plagues, drought, long winters. Religions arose in part as attempts to propitiate and control, if not much to understand, the disorderly aspect of nature. The scientific revolution permitted us to glimpse an underlying, ordered universe in which there was a literal harmony of the worlds. That's Johannes Kepler's phrase. If we understand nature, there is a prospect of controlling it, or at least mitigating the harm it may bring. In this sense, science brought hope. Most of the great deprovincializing debates were entered into with no thought for their practical implications. Passionate and curious humans wished to understand their actual circumstances, how unique or pedestrian they in their world are, their ultimate origins and destinies, how the universe works. Surprisingly, some of these debates have yielded the most profound practical benefits. The very method of mathematical reasoning that Isaac Newton introduced to explain the motion of the planets around the sun has led to most of the technology of our modern world. The Industrial Revolution, for all its shortcomings, is still the global model of how an agricultural nation can emerge from poverty. These debates have bread and butter consequences. It might have been otherwise. It might have been that the balance lay elsewhere, that humans by and large did not want to know about a disquieting universe, that we were unwilling to permit challenges to the prevailing wisdom. Despite determined resistance in every age, it is very much to our credit that we have allowed ourselves to follow the evidence, to draw conclusions that at first seemed daunting. A universe so much larger and older that our personal and historical experience is dwarfed and humbled. A universe in which every day suns are born and worlds obliterated. A universe in which humanity, newly arrived, clings to an obscure clod of matter. How much more satisfying had we been placed in a garden custom-made for us, its other occupants put there for us to use as we saw fit. There is a celebrated story in the Western tradition like this, except that not quite everything was there for us. There was one particular tree of which we were not to partake, a tree of knowledge. Knowledge and understanding and wisdom were forbidden to us in this story. We were to be kept ignorant. But we couldn't help ourselves. We were starving for knowledge, created hungry, you might say. This was the origin of all our troubles. In particular, it's why we no longer live in a garden. We found out too much. So long as we were incurious and obedient, I imagine, we could console ourselves with our importance and centrality, and tell ourselves that we were the reason the universe was made. As we began to indulge our curiosity, though, to explore, To learn how the universe really is, we expelled ourselves from Eden. Angels with a flaming sword were set as sentries at the gates of paradise to bar our return. The gardeners became exiles and wanderers. Occasionally, we mourn that lost world, but that, it seems to me, is maudlin and sentimental. We could not happily have remained ignorant forever. There is in this universe much of what seems to be design. Every time we come upon it, we breathe a sigh of relief. We're forever hoping to find, or at least to safely deduce, a designer. But instead, we repeatedly discover that natural processes, collisional selection of worlds, say, or natural selection of gene pools, or even the convection pattern in a pot of boiling water, can extract order out of chaos and deceive us into deducing purpose where there is none. In everyday life, we often sense, in the bedrooms of teenagers or in national politics, that chaos is natural and order imposed from above. While there are deeper regularities in the universe than the simple circumstances we generally describe as orderly, all that order, simple and complex, seems to derive from laws of nature established at the Big Bang, or maybe earlier, rather than as a consequence of belated intervention by an imperfect deity. God is to be found in the details, is the famous dictum of the German scholar Aby Warburg. But amid much elegance and precision, the details of life in the universe also exhibit haphazard, jury-rigged arrangements and much poor planning. What shall we make of this? An edifice abandoned early in construction by the architect? The evidence so far at least, and laws of nature aside, does not require a designer. Maybe there's one hiding, maddeningly unwilling to be revealed. Sometimes it seems a very slender hope. The significance of our lives and our fragile planet is then determined only by our own wisdom and courage. We are the custodians of life's meaning. We long for a parent to care for us, to forgive us our errors, to save us from our childish mistakes. But knowledge is preferable to ignorance. Better by far to embrace the hard truth than a reassuring fable. If we crave some cosmic purpose, then let us find ourselves a worthy goal. Chapter 5. Is there intelligent life on Earth? They journeyed a long time and found nothing. At length, they discerned a small light, which was the Earth. But they could not find the smallest reason to suspect that we and our fellow citizens of this globe have the honor to exist. That's from Voltaire's Micromegas, 1752. There are places in and around our great cities where the natural world has all but disappeared. You can make out streets and sidewalks, autos, parking garages, advertising billboards, monuments of glass and steel, but not a tree or a blade of grass or any animal, besides, of course, the humans. There are lots of humans. Only when you look straight up through the skyscraper canyons can you make out a star or a patch of blue, reminders of what was there long before humans came to be. But the bright lights of the big cities bleach out the stars, and even that patch of blue is sometimes gone, tinted brown by industrial technology. It's not hard going to work every day in such a place to be impressed with ourselves, how we've transformed the earth for our benefit and convenience. But a few hundred miles up or down, there are no humans. Apart from a thin film of life at the very surface of the earth, an occasional intrepid spacecraft, and some radio static, our impact on the universe is nil. It knows nothing of us. You're an alien explorer, entering the solar system after a long journey through the blackness of interstellar space. You examine the planets of this humdrum star from afar. A pretty handful. some gray, some blue, some red, some yellow. You're interested in what kinds of worlds these are, whether their environments are static or changing, and especially whether there are life and intelligence. You have no prior knowledge of the Earth. You've just discovered its existence. There's a galactic ethic, let's imagine. Look, but don't touch. You can fly by these worlds. You can orbit them, but you are strictly forbidden to land. Under such constraints, could you figure out what the Earth's environment is like, and whether anyone lives there? As you approach, your first impression of the whole Earth is white clouds, white polar caps, brown continents, and some bluish substance that covers 2/3 of the surface. When you take the temperature of this world from the infrared radiation it emits, you find that most latitudes are above the freezing point of water, while the polar caps are below freezing. Water is a very abundant material in the universe. Polar caps made of solid water would be a reasonable guess, as well as clouds of solid and liquid water. You might also be tempted by the idea that the blue stuff is enormous quantities, kilometers deep, of liquid water. The suggestion is bizarre, though, at least as far as this solar system is concerned, because surface oceans of liquid water exist nowhere else. When you look in the visible and near-infrared spectrum for telltale signatures of chemical composition, sure enough, you discover water ice in the polar caps and enough water vapor in the air to account for the clouds. This is also just the right amount that must exist because of evaporation, if the oceans are in fact made of liquid water. The bizarre hypothesis, liquid water oceans, is confirmed. The spectrometers further reveal that the air on this world is 1/5 oxygen, O2, 2 oxygen atoms bound together. No other planet in the solar system has anything close to so much oxygen. Where does it all come from? The intense ultraviolet light from the sun breaks water, H2O, down into oxygen, and hydrogen, the lightest gas, quickly escapes to space. This is a source of O2, certainly, but it doesn't easily account for so much oxygen. Another possibility is that ordinary visible light, which the sun pours out in vast amounts, is used on Earth to break water